Okay, you should be watching this video after you filled in all these notes. I'm just going to try to summarize some of the concepts for you. This one right here, so you were just trying to, just like what we did the other day with the own vehicle and don't own vehicle. We had two students. So you have two cars. You could have lemon, 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 not, lemon, and then not. If X is the number of lemons in the sample, and this one there's 2, and this one there's 1, and this one there's 1, and this one there's 0. You can find all those probabilities. Remember, it's not 50-50, so you have to go through and find the probabilities, and then you create that probability distribution. This scenario in which you have just two outcomes for each thing, so lemon or not, it's called a binomial experiment. And so there's a fixed number of trials. In this case, we just had two cars. The trials are independent. So whatever the first car was, if it was a lemon or not, it didn't impact what the second car was. Each trial has two outcomes, so lemon or not, and the probabilities remain the same for each trial. So each time we did this, there was a probability 0.05 it would be a lemon. This is going to be the most widely used discrete distribution. Success doesn't necessarily mean good or favorable. It's just the probability of what you're looking for. So success doesn't have to mean a good thing. All right, if I wanted to create this probability distribution in my calculator, so the one that we just did up here, then all I would have to do is, in my calculator, I would type this command. So let's bring up this calculator here. Alright, so what I would do on this calculator, if I just wanted to create the probability distribution, I'm going to type in second vars, which gives me my distribution menu. These are all the distributions that we will cover in this class. I'm going to go down and find the binomial one. There's two binomial ones. Oops, I went a little too fast. There's two binomial ones. The one that I am interested in is just the binom PDF one. I'm going to press enter. I want to type in my number of trials. In this case it was 2, and then my probability of success. In this case, when I was talking about the lemon, I would do 0.05. I'm going to stop there. I'm going to store this in, and I press enter. Alright, those are the probabilities that you saw at the top of this page right here. These probabilities right there. So if you look then at your calculator list, so if I go to stat, edit, press enter, right here in that list, those are those probabilities. I'm going to just clear out list 1 here. And what I could do here is I can type in 0, and then 1, and then 2. And if you look right, so on my screen right there, I have 0, 1, 2, and then all those probabilities, and that is the same thing that I have right here. So I just recreated that probability distribution in my calculator, so that's how you can do that. Alright, here's your formula. Everything here is defined. This is just like the combination formula. Instead of using R, it's X in this one, but it's really no different. N is your number of trials, P is your probability of success, Q is your probability of failure, X is the number of successes in N trials, and N minus X is the number of failures. So instead of drawing that tree diagram, which wasn't too bad for just two outcomes, or two cars. However, if we had more cars, I wouldn't want to do that. But I can use this formula to find the probability of getting one lemon when selecting two cars using the binomial. So I'm trying to find exactly one lemon, so X is equal to 1. So there was a sample of 2. My probability of success is 0.05. My probability of failure is 0.95. And I'm looking for a success of just 1. So I plug those things into the formula. And what you'll notice there, so when I plug that into the formula, I get 0.05 to the first and 0.95 to the first. And this works out to just be 2. So I've got 2 times 0.05 times 0.95. If you go back to that first page how many ways could we get just one lemon? There's 2 ways. So what, in both of those ways, I'm just doing 0.05 times 0.95. I might be flipping it, but I'm still multiplying the same 2 numbers. But since there's 2 ways to do that, that combination part of the formula takes care of the 2 ways. So I just need to account for those probabilities twice. So if I extend this n to even a larger number, it'll still work out. It'll just tell you how many times you need to account for this combination here. These are the, I think this might be from the 83. It looks like the 84s are A and B, but we're going to use the PDF command and the CDF command. The PDF command only works for exact problems. So like in this one here, x is equal to 1. So for what I could have done for this one, for the lemon problem, if I go back to my calculator here, I can do, so I'm going to go back to that second vars again to get those distributions. Oops, it just goes a little bit too fast here on this screen. Alright, the binomial PDF. Alright, I want to type in n. In this case, I was dealing with 2 cars. My probability of success, or probability of getting a lemon, was 0.05. And then the probability, and I was looking for exactly 1. So I press enter, and there's my probability, 0.095, which, if I go back up there, that's the answer we got there, okay? So you can use this command. So, alright, so this one here, in tossing a coin 10 times, what's the probability of getting 8 heads? So I want to find probability that x is exactly 8. So I'm doing binomial PDF. 10 is my number of trials. My probability of success, the probability of getting a head, is 0.5, and then there's 8. You type that into your calculator, and this is the answer that you get. All these problems here are exactly problems, so you're just finding one thing, and the answers are given to you for each of those problems. Alright, this one says at most. The difference about at most, so in tossing a coin 10 times, what's the probability of getting at most 8 heads? So x is less than or equal to 8. I want at most 8, so I want 0 through 8. I could go through and do the PDF for 0, and the PDF for 1, and the PDF for 2, all the way up to the PDF for 8, and add them all together. However, our calculator does have that other command, the binomial CDF command. And the CDF, the C just stands for cumulative. So if I want everything less than or equal to a value, in this case 8, I can just do binomial CDF, the number of trials, in this case was 10, the probability of success, 0.5, and then K, the number of successes I'm looking for. So if I go to my calculator again, I go to second vars, I'm going to find that binomial CDF command now, and again, like I said, on these 84s, it looks like it's B. And I'm going to do 10, comma, 0.5, comma 8. Sorry, my little 2-year-old is sitting with me and he's coughing, so that's what you keep hearing. Alright, so then this is the answer that we get, which is the answer that I had written right here. Alright, then you can go through these ones, you can check your answers. Alright, for at least problems, so if you recall the probability of at least, so all the individual probabilities have to add up to 1. So I can always subtract, I can always use the complement rule, so I can subtract what I don't want from 1 to get what I do want. And that's what we have to do in this case, because our calculator only has the PDF command and the CDF command, and the CDF command only gives you up to 0 up through what the number that you're looking for. So if I wanted at least, so if I wanted, in this example right here, I wanted at least 8 heads, I'm going to do 1 minus the probability of x being less than or equal to 7, because I want to subtract out 0 through 7. And when I do that, I will just be left with 8, 9, and 10. So I do 1 minus the binomial CDF of 10, comma, 0.5, comma, 7. So on my calculator, you can see I'll do 1 minus, I go to second vars, I'm going to go find that binomial CDF command, press enter. I've got 10, comma, 0.5, comma, And what was I doing in this one? I wanted to do 7 because I wanted to subtract out 0 through 7. And then I press enter. And there's the answer that I have there. You can generalize this formula, so if you're trying to do at least k, it just is 1 minus the binomial CDF of n, comma, p, comma, k minus 1. So like at least 8, it was just 8 minus 1, so that's why I have the 7 there. Go ahead and do the rest of those. Alright, the last type of problems are interval problems, and this, you probably can't tell, it looks like a plus, but that is actually a minus there. So if you wanted in this one, I wanted the probability of getting between 4 and 8. Again, I only have those 2 choices for commands. So what I do here is I do the binomial CDF of up to 8. So I get 0 through 8 for that command, but that's not what I wanted because I only wanted 4 through 8. So what I am going to do is I'm going to subtract out 0 through 3. So I'm left with just 4 through 8. So I type those 2 things in to my calculator, so I can do that for you here. Oops, and it's going a little fast on me again. And I'll do then my 10, comma, my 0.5, comma, 8. And then I'm going to subtract. And I want to subtract, oops, that didn't work. I want to subtract out the binomial CDF of 10, comma, 0.5, comma, 3. And I press enter, and hopefully that is the answer I got there. Yes, it is. Okay? So you can generalize this. You would first do the upper number. You do n, comma, p, comma, b. So that's what I did here, 10, comma, 0.5, comma, 8, which was my upper number, minus, and then the bottom part is n, comma, p, comma, a minus 1. So in this case, a was 4, so 4 minus 1, I get my 3. And then you can do this one here to make sure you get that answer. And just some things here. If your probability is 5, your distribution is going to be symmetric. If it's less than 0.5, so most of your successes are going to be down here, it'll be skewed right. If it's greater than 0.5, it'll be skewed left. So this is something else to think about.